Okay, in this video I'm going to go over how to answer the NCEA paper, Demonstrate Understanding of Properties of Selected Organic Compounds. Now that's the 2.5 Level 2 Chemistry paper, or the Achievement Standard 91165. Now this is a 2023 paper, and so, well, let's get into it. So there are 3 questions in this paper. Each question is worth 8 marks. So let's just go over how we might answer these. Okay, question 1 here. Assortment of organic compounds is listed below. So here's a table. We're going to expect this in every one of the exams that they give us. They've given us a couple of structures and a couple of names. So with the structures, they want us to give the names. With the names, they want us to draw the structures. And don't be fazed by them. They'll always say this, which is complete the table by drawing the structure or giving the IUPAC systematic name. Now IUPAC is just a convention that internationally is used to write the names for given organic molecules, or to draw the molecules from the names. So at International Union of Physical and Analytical Chemists. So it's something you may not have noticed, but that's just the name of the system that you would have done when you practice it in class. Okay, so for the first one, we can see that there are 5 carbons, and there is a chlorine substituent, or a chlorine atom, coming off the first carbon. So if we have a chain of 5 carbons, of course this is going to be pentane. And because we have this halogen chlorine coming off the first carbon, because remember we number from the side that gives us the smallest number, this is going to be called 1-chloropentane. Now the next one here is methanoic acid. If we remember, meth means that there is 1 carbon. So this is an acid with 1 carbon. And we remember that anoic acid is a carboxylic acid, which means there is a carbon double bond O with an OH group joined to it. So that's why this molecule is just going to be a carbon double bond O with an OH and a hydrogen coming off the left here. Now methanoic, yes, that's correct. There is just 1 carbon. So what about molecule C here? We can see there are 4 carbons in a row, so we go meth, eth, prop, bute. There's going to be bute 4 carbons. This is going to be butane. There is this NH2 group off here, which means this is an amine, so this is going to be butanamine. Apart from, we have the amine group coming off the second carbon, so this is going to be butan-2-amine. We could also actually write this, and you won't get it wrong this way, if you were to say 2-aminobutane. But I would just write butan-2-amine here. And the last one here is propan-1-ol. Okay, so remember we said meth, eth, prop, bute. That's 1, 2, 3, 4. Prop is 3 carbons in a row. And coming off the first carbon, we have an ol, an alcohol group, an OH group. So this is what it looks like. Now we can draw, when we draw these molecules, we can draw them in expanded form, or we can draw them in condensed form, and it doesn't matter as long as you have the correct number of hydrogens joined with each attached to each carbon. The other thing you should note when you're drawing an OH group, it's really important, or an NH2 if you have to draw that, is that you have to ensure that the bond from the carbon goes directly, is bonded to the oxygen, not between the oxygen and the hydrogen, or not to the hydrogen, but is bonded to the oxygen. Okay, so these are the 4 correct answers. If we want to get a grade for this, well, it was pretty simple in 2023. They just said if you got 2 or 4 of these correct, they give you an achieved. There is no merit or excellence available here, and that's as much as you can get for this question. Let's go look at the next part.
Right, let's look at constitutional isomers or structural isomers and how to answer exam questions on them. In particular, I'm going to look at 2021, 2022 and 2023 NCEA exams. We're looking at the organic chemistry exam. If you want to look at the specific exams and the questions so you can follow through with me, just look at the reference at the right there. Just put that into your Google search engine and you should be able to find the papers and then have a go at these yourself. Okay, structural isomers, or sometimes called constitutional isomers. What are they? These are when we have the same number and type of atoms but bonded in a different structural way. So this first question asks us to unpack this, and the very first thing they say is that there is 4 compounds, a variety of alkanes and alkenes. Remember, alkanes contain just carbons and hydrogens with single bonds, and alkenes contain carbons, hydrogens, and a double bond. So we've got 4 compounds here. Part A, they say 2 compounds are constitutional or structural isomers of one another. That means that they must meet the requirements of being structural isomers. That is, they must have the same atoms and same type and number of atoms, but arranged in a different way. So the very simple thing to do here is to count up the number of atoms in each one. So if I went to compound 1, I would see there are 4 carbons, whereas in compound 2, 3, and 4, there are 6. So compound 1 is definitely out of there, right? So that's a no-go. When I go look at compound 2, it looks kind of different to compound 3 and 4. So let's look at 3 and 4. Well, compound 3 has a double bond, so it's got 6 carbons and 12 hydrogens, where compound 4 has 6 carbons and 14 hydrogens. So they do not have the same number and type of atoms, so they are not constitutional isomers. Well, let's have a look at compound 2 then. Does it have anything similar with 4 and 3? It's in a circle. We call this a cyclic compound. It has 6 carbons and 12 hydrogens. So it's actually the same number of carbons and hydrogens as compound 3. So compound 2 and compound 3 have the same number and type of atoms. Now I've got to justify why I chose these two. Well, I'll just go over what I just said. Both compound 2 and 3 have the same molecular formula. And we can unpack this further. We could say they both have 6 carbons and 12 hydrogens, or the same number and type of atoms. The second thing that they have that makes them constitutional isomers, because they have to have something that's the same, the number of atoms and type of atoms, and something that is different. We can tell them apart. What they have that is different is that the atoms are bonded in different arrangements. So I want to tell them what the different thing is, bond in different arrangements, but I actually want to give some specific detail here. So what I'll give a detail about compound 3. I'll say in compound 3 the 6 carbons are arranged in a circular or a cyclic fashion, so they're arranged in a circle. When 3 they're arranged in a line, and in fact there's a double bond between the 3rd and the 4th carbon here. So I've given more detail here just to unpack the answer a bit more and make sure that it's a robust answer to this question. Now when I look at the marking schedule for this Achievement Standard 91165 for 2021, I get an achieved point here for identifying the 2 that are structural or constitutional isomers of each other. I get another for explaining why. So if I said, hey, they've got the same molecular formula, but they're arranged in, or the bonds, they're joined in different ways, I get another A. But if I can actually link, and link here means me giving specific detail about each compound. That is, the compound 2, the carbons are linked in a circle. Compound 3, they're all in a line. That detail takes it to a merit point. And that makes this a lot more marks that we've collected for this question if we can give just a wee bit more detail. Let's have a look at the next question, 2000. Okay, if we look at the 2023 question, there wasn't a question on this in 2022. So just on this small sample, 2 out of 3 times we'll have it. So it's good to be prepared to answer this question. So here they've got compound A, and it says it forms 2 different products when reacted with KOH. Now, because they've got KOH there, the first thing that we have to think about is, okay, we remember we only use potassium hydroxide when we have it as 2 different conditions. One dissolved in water, that is KOH brackets aqueous, and one dissolved in alcohol, KOH brackets alcohol. We have to compare and contrast these 2 types of reactions. Talk about the conditions, that's just what I said, alcohol or aqueous. State the type of reaction. Remember, if it's an alcohol, it's going to produce an elimination reaction. If it's aqueous, it's going to produce the alcohol. And give the formula of the products. So we go through similar as we did to the other question. KOH alcohol is an elimination reaction where the Cl and an adjacent hydrogen is removed to make a double bond. We will say in this question, because it's at the end, there is only one option, one answer here, okay, because we only ever remove the hydrogen off the second carbon because it has to be adjacent. Produces an alkene pent-1-ene. Here it is, the structure. Remember, I could have drawn that out as a fully expanded, or I can draw it condensed in this form. The KOH aqueous, okay, if I add that reagent to this, it's going to substitute the chlorine here with a hydroxy group or an OH group, producing the alcohol pent-1-ol, and then I'm going to draw the alcohol that it would produce. And this here is our full answer. So when we mark this, if we talk about, there are two different conditions, KOH alcohol, KOH aqueous, which they didn't tell us, they give us an achieved. If we had one of the products correct, they would also give us achieved, but only an achieved for one of these ideas. If we correctly link the condition of the product to the reaction type, so if we said KOH alcohol was elimination, for one reaction we get a merit. Okay, that seems pretty straightforward, pretty easy, that one. If we elaborate upon the reactions of KOH with reaction types and products, so if we actually do the full thing here, then we're going to get the excellence. Okay, so we're going to say we need this for an elimination, KOH alcohol for elimination, to produce this product. We're going to link them all together. We'll get this first paragraph and then the second one we need as well to get the excellence. Look, don't be afraid to put the extra detail in, like explain how an elimination reaction works, that we remove the functional group and adjacent hydrogen to produce a double bond, or the substitution that we replace one with the other. Putting that detail in is often used as a threshold for excellence, even though on the marking schedule they say that it is an excellence to do something simpler. Okay, I hope this has helped. If you want any more help with the exam questions for chemistry, don't forget to look at my other videos. Okay, let's look at the 2023 paper. We can see here that we have two molecules and they want us to distinguish between the different products of these two reactions using bromine water. So we're going to describe how we would carry out the reaction here. So as an alkene, we're going to say this one is an alkene. It contains a double bond. When bromine water is added, it undergoes an addition reaction. The orange bromine water rapidly decolorized when added and shaken with pent-2-ene, and we get this reaction here. So I guess the first step here is to say that we add the bromine water to each of the samples. Then we've got this explanation that we get an addition reaction. The orange bromine water rapidly decolorizes. I mean, it's pretty standard. This is what we've gone over the other ones. This is a bit more simplistic. I'm not going into detail on how the addition reaction works because it just wants me to explain, not to discuss or compare and contrast, which are actually more higher level explanations. Propane 1-ol does not react, so this one here will say does not react with bromine quickly, and the orange color from the bromine water will stay or persists. Answers. If we wrote the correct observation for one of these, so I said even the last bit here, the bromine water persists, then I get an achieved mark. If I link the observation to the compound reacting to distinguish the product, so if I talked about the bromine water is changing color when we add it to the pent-1-ene because it is undergoing an addition reaction, we're going to get the achieved merit mark here.
Okay, so for the total of question 1 in 2023, if we add up the grades from all the sub-questions, what we can do is we can get the mark that we are awarded for this question. Now, to get an E8, you needed 2 of the excellence points. To get an E7, you need 2 of the excellence point with a minor error in one of the parts that you would use to go towards the excellence. To get an M6, you needed 4 merit points, an M5 3 merit points, and you would have a 4 3 2 1 A's to get an A4 A3 N2 and N1. Okay, let's look at the next question.
This one, they've just given us one example, but they've asked us to explain why it is. Is it a secondary, tertiary, or primary alcohol, and why? So again, circle the functional group, asterisk the carbon that it's joint to, and then count how many are adjacent or attached directly to the carbon that is joined to the functional group. There is 1, 2. This is going to be secondary. Hexane 2-ol is a secondary alcohol, as the carbon atom that is attached to the OH functional group, that's the asterisk one, is bonded to 2 other carbons. Wow, that was a really quick answer here, and we get an achieved and a merit if we've practiced these questions. Notice similar theme throughout all of these classification questions. If you practice them, you will do well at it. Okay, good luck, and we'll see you in the next video. 23 question. So this is also going to be Zaitchev's rule. I just put the red bit in here. We have this compound hexane 2-ol, and we're told that when we add concentrated sulfuric acid, 2 products E and F will form. Very similar to the other questions. We know this is going to be an elimination reaction, so we should say that. We can see here that we have the OH off the second carbon, and we can take the hydrogen either off the first carbon or the third carbon. Noticing that the third carbon is the one with the least hydrogens, that's adjacent to the carbon with the functional group, and the first carbon is the one with the most hydrogens adjacent to the carbon with the functional group. So this is an elimination reaction. We're removing an OH group and an H, or a water molecule in total. And the H is attached to an adjacent carbon that's removed. Remember, it's always adjacent. We're only looking at the carbon directly attached to the carbon with the functional group. This is asymmetric, so we will get a different product depending on which side of this carbon we take it from. There are 2 possible options here. We can either take it from 1, or we can take it from 3. Now, if it is removed from the adjacent carbon with the least hydrogens attached, that is 3, okay, that will happen the majority of the time because it has because it has the least hydrogens. We are going to produce hex-2-ene. If we take it away from compound 1, the minority of the time will produce hex-1-ene. Hence, there are 2 options, hex-1-ene and hex-2-ene. So if we go to mark this, the first things is, can we identify that this molecule is asymmetric? Yes, we did, and we used the word asymmetric. Did we assign correctly which one was going to be major and minor? Yes, or we could have stated that how we could identify major and minor products. The next thing we do is, did we explain why 2 products are formed? So this is more detailed. Did we say that because there are 2 different options, we will form 2 different products? Did we explain how the major and minor products can be identified? And the last thing is justify why 2 products are formed and how to identify major and minor products. So when they say identify, I guess they're using the wrong word here. What they're saying, did we assign the correct product to be the major and the correct product to be the minor? That's what they mean by identify here. So if I go back and explain this here for the merit, it's explain how major and minor products can be assigned. Okay, so how did I come up with the major product being hex-2-ene? Can I explain why the minor product is hex-1-ene? And that's how these questions are marked, and hopefully you've practiced some of these answers and you'll be well prepared for any future exams. Good luck.
Right, so this is the last part of question 2, and in the last part here it says, can we give the structural or constitutional isomer of hexane 2-ol that would form only 1 product when reacting with concentrated sulfuric acid? We have to recognize here that concentrated sulfuric acid will facilitate or make an elimination reaction happen when we put it with an alcohol. It will remove the OH group and the hydrogen group from an adjacent carbon. Now, if the OH group is attached to anything but the end carbon, there are always 2 choices available. So therefore you can get 2 different products a lot of the time if it's asymmetric. However, if you want to only get 1 product, you have to have the OH attached to an N carbon or to be a primary alcohol. This is one of the isomers of hexane 2-ol that would produce only one product because it would remove the OH from the carbon and the hydrogen from an adjacent carbon when it undergoes the elimination reaction, and there is only one carbon that's attached to the carbon with the OH, so there will only be one product. However, this isn't the only isomer. You could draw primary isomers that have 5 carbons in the main chain and some with 4 in the main chain, but this is most probably the one that most people would have drawn. If you were able to draw a primary isomer, you gave a correct structure, you would get an achieve point here. So as the last question of this question, let's see what we had to do to get our grades for question 2. So for question 2, 2 E's for an E8, 2 E's with a minor mistake for E7, 4 M's for M6, 3 M's for M5, 4 A's for A4 and 3 for A3, 2 for N2 and 1 for N1. Okay, let's go on to the next question.
Okay, let's look at the 2023 paper. We can see here that we have 2 molecules and they want us to distinguish between the different products of these 2 reactions using bromine water. So we're going to describe how we would carry out the reaction here. So as an alkene, we're going to say this one is an alkene. It contains a double bond. When bromine water is added, it undergoes an addition reaction. The orange bromine water rapidly decolorized when added and shaken with pent-2-ene, and we get this reaction here. So I guess the first step here is to say that we add the bromine water to each of the samples. Then we've got this explanation that we get an addition reaction. The orange bromine water rapidly decolorizes. I mean, it's pretty standard. This is what we've gone over the other ones. This is a bit more simplistic. I'm not going into detail on how the addition reaction works because it just wants me to explain, not to discuss or compare and contrast, which are actually more higher level explanations. Propane 1-ol does not react. So this one here will say does not react with bromine quickly, and the orange color from the bromine water will stay or persists. Answers. If we wrote the correct observation for one of these, or so I said, even the last bit here, the bromine water persists, then I get an achieved mark. If I link the observation to the compound reacting to distinguish the product. So if I talked about the bromine water is changing color when we add it to the pent-1-ene because it is undergoing an addition reaction, we're going to get the achieved merit mark here. Okay, let's look at the 2023 paper. We can see here that we have 2 molecules and they want us to distinguish between the different products of these 2 reactions using bromine water. So we're going to describe how we would carry out the reaction here. So as an alkene, we're going to say this one is an alkene. It contains a double bond. When bromine water is added, it undergoes an addition reaction. The orange bromine water rapidly decolorized when added and shaken with pent-2-ene, and we get this reaction here. So I guess the first step here is to say that we add the bromine water to each of the samples. Then we've got this explanation that we get an addition reaction. The orange bromine water rapidly decolorizes. I mean, it's pretty standard. This is what we've gone over the other ones. This is a bit more simplistic. I'm not going into detail on how the addition reaction works because it just wants me to explain, not to discuss or compare and contrast, which are actually more higher level explanations. Propane 1-ol does not react. So this one here will say does not react with bromine quickly, and the orange color from the bromine water will stay or persists. Answers. If we wrote the correct observation for one of these, or so I said, even the last bit here, the bromine water persists, then I get an achieved mark. if I link the observation to the compound reacting to distinguish the product. So if I talked about the bromine water is changing color when we add it to the pent-1ene because it is undergoing an addition reaction, we're going to get the achieved merit mark here. One last one. This is last year's paper, 2023. Well, last year as I record this is the start of 2024. So here's the question. Propose a structure of a compound with a molecular form of C4H8 that forms a geometric isomer. Okay, so a bit of creative work here, but we can see that there's 4, so it's going to be a butene. And look, if we've done enough practice in organic chemistry, we're going to know it's going to be but-2ene. It can't be but-1ene because then you would have 2 hydrogens coming off the first carbon. We draw the structure. Here it is. It says here, you do not need to draw the cis or trans arrangement, but look, naturally when I draw them expanded, it's either going to be cis or trans, and you can see this is a trans here, but that's fine. So I've drawn that. Now I've got to restate the requirements of geometric isomerism. So again, we're going to, I've set up here, I've put 2 and 3 to help me just tie my answer to the graphical representation. So this compound has a double bond, prevents rotation, holds the atom groups of the double bond in a fixed position, or attach the double bond. Okay, this statement, notice, is needed every single time, right? So this is achieved. This is going to give us, get our 2 achieved grades for us. And to get to the next stage, we just need to clearly say, okay, these are 2 different groups because one is, or atoms, because one is a hydrogen and one is a CH3. So coming off 2, there is a hydrogen and a CH3. That's what makes them different. And coming off 3, there is a hydrogen and a CH3. Hence, we have our answers. Draw the structure, we get an achieved point. If we state the requirements, first bullet point, we get an achieved point. If we explain why it's needed, actually that's this part here, fixed position, that's a merit point. Well, that's awesome. So actually if we do this part here and the first bullet point, if we draw the diagram in the first bullet point, we're going to get achieved merit. Excellence is this detail, okay? Justifies the proposed structure by linking both criteria. So I'm linking by putting the specific groups and the specific atoms joined to the number of the carbon. I'm linking what I'm talking about to the actual structure. And in this case, actually, sorry, the 4th one is a merit point. So there's 2 merit points to achieve. Now, it's interesting. Sometimes they make it an excellence answer. Sometimes it's 2 merits. But if you go through this whole paper, you can see that this question, geometric isomerism, is a real linchpin. And if you just practice these and you make sure you're familiar with using the correct phrasing, with drawing the molecules correctly, and linking, okay, linking the specific groups or atoms off the specific carbons of the double bond, when you write your answer, you're going to get the maximum grades from this, and you're going to go really well on the exam. Hey, good luck with your practice, and thanks for listening. 23. Okay, 2023, a wee bit harder here because we actually have to draw the constitutional isomers. Now, when I draw constitutional isomers, I always like to start, I draw them out fully expanded like they are here, and I look at it, and this is the first one. They've drawn it for us. It says draw and name the 4, but actually they've done the first one. Oh, they've said that here. Wow, my bad. Okay, so there's 4 carbons in a row. There's an OH coming off the first one. Well, if I want it arranged in a different way, but exactly the same atoms, of course, I could put the OH here off the second one. And there we go. So this is, what's its name? Well, this is called butan-1-ol because it is an alcohol that has the OH coming off the first carbon. This one here is obviously the OH coming off the second carbon. So it's butan-2-ol. Because they have 2 different names, it gives me verification that they are actually different isomers of each other. Okay, so I could put an OH off the next carbon along, but remember how we name things. We always name from the side that gives the functional group its lowest number. So if I put it coming off this carbon here, it would still be butane 2-ol, so that's not a different version. If I put the OH off the carbon extreme on the left, it would also be butane 1-ol again, so it's just the first one reflected or flipped. So we have to think a bit different here. I know what we can do. Let's start by doing 3 in a row and put 1 carbon off the middle. Now we can put the OH off the first carbon, or off a carbon. We can make it a primary alcohol. We can put off the carbon that's only joined to one other carbon. In this case, this is propane 1-ol, but there's a methyl group coming off the second carbon, so it's 2-methyl propane 1-ol. You can get away here by just calling this methyl propane 1-ol, because there is no other way that you could make a methyl propane 1-ol without putting it on the second carbon. Okay, what is the fourth possible one? Well, I can't change the backbone structure anymore. I can't arrange these carbons in a different way, but what I can do is move this OH so it comes off the middle carbon. Now, because it's attached to the middle carbon, this is actually a tertiary alcohol, but this is different to the one on the left. And this is 2-methyl propane 2-ol. Okay, so these are the 4 different structures. This is actually quite, for me, in structural isomerism questions, this is one of the most challenging parts I see with students. And look, you really have to practice finding different examples and drawing all the possibilities and making sure that you eliminate any doubles ups and only get the ones that are the structural isomers of each other. Okay, real easy now. We can do the last bit. Can we justify why they're structural isomers? Why they are is because they have the same molecular formula. Okay, they have 3 carbons. They have 10 hydrogens and 1 oxygen. But why? What is different that makes them be structural isomers? Well, they have atoms bonded in different arrangements. See, 2 of these have 4 carbons in the longest chain, in the parent chain. The other 2 have 3. See, arranged differently. Also, in the first 2, the OH, in one of them it comes off carbon 1, in the other it comes off carbon 2. Notice in the last 2 sentences, or the second part of the complex sentences of the second sentence, and the last sentence, I've placed in detail here so I can get the best possible mark. So, answers. Did I put all the correct compounds? Yes, of course I did. Correct explanation? Yep. Same molecular formula, but different arrangement of atoms. Did I link the features to what I'm talking about, but I give some specific detail? Yes, I did. Awesome, I get the merit. Okay, and that is how we answer these questions on structural or constitutional isomers.
Right, so if we now take all the subparts from question 3, we can and find all the marks that we were awarded for our different answers. We can count up and see what mark would be for this question. Now, very similar to the other questions with 2 E's for E8, 2 E's with a minor mistake for E7. To get an M6 in this question, you only needed 3 M's, and M5 was 2 M's, and then 4, 3, 2, and 1 achieves for our A4, A3, N2, and M1. So if we take the mark from this third question, and we take the mark from the second question, and the mark from the first question, and we add them all together, we'll get a number out of 24. Now, depending on what number you get from 24, depends what you get for this paper. This paper was quite generous because you got not achieved if you got 0 to 6, but if you got 7 to 13, you got achieved, 14 to 18 a merit, and 19 to 24 was an excellence. Okay, if you found me going through this paper with you useful, have a look out for my other videos. I do other videos on this standard, other level 2 standards. I've even got a level 2 physics standard if you need some help with that.